Okay, so linear combination, we have understood the idea that, so for example, if we have y, so c1 y1 plus c2 y2 plus c3 y3 is the idea that y1 y2 and y3 is a linear combination of y. That idea we have seen already. Okay, so now this idea, how it will be converted to the linear independence and dependence by having your y as 0 0 0. Okay, so when you wanted to prove if this system is linearly independent or dependent, in that case you have to always consider your y as 0 0 0. It means that when you are generating your matrix for y1, so y1 y2 y3 will be written in term of columns, so 1 2 3 first column, 4 5 6 second column, 7 8 9 third column. So we have written in columns c1 c2 c3 0 0 0. Okay, because y is not given, so whenever the linear independence and dependence question is there, so by default you have to consider y or x, whatever the terminology is used, so you have to take it 0. So the question is the same, that we wanted to find the linear combination. Okay, linear combination mean we have to find the value of c1 c2 and c3. Okay, we have to find the value of c1 c2 and c3. So after having this matrix, you simply 1 2 3 4 5 6 7 8 9 dot 0 0 0. So we have written augmented matrix, because our objective is to find the value of c1 and c2 c3. Okay, so now we will apply the row operations again. So what should be the row operation? The first row will remain the same. The opposite sign of 2 is minus 2. Minus 2 plus 2 answer is 0. Minus 8 and 5 minus 3. Minus 14 and 8 minus 6. Minus 2 multiplied by 0 0, and 0 is there. Minus 3 plus 3 answer is 0. Minus 12 and 6 minus 6, and minus 21 and 9 minus 12 and 0. Okay, so now we'll try to make the leading element 1 in the second position, the second non-zero element. So the second non-zero element in the second row is minus 3. So we have to make, because this is a leading element and we want to make the leading element 1. Okay, so the first method, I'm just going to write what previously I have done. So I have done this one previously to get it to reach at this point. Now first row again will remain the same, and we are multiplying row 2 by minus 1 by 3. Okay, 1 2 0 0 minus 6 minus 12 0. So 1, 4, 7, 0 again will remain the same. 0, 1, 2, 0 will remain the same. 0, 0. Because the opposite sign of minus 6 is plus 6. Plus 6 minus 6, answer is 0. 12 and minus 12, answer is 0. Okay. So when this type of situation comes, so you could easily identify that C2 plus C2 plus C2 plus C3, 2C3 equal to 0, isn't it?
Yes.
So it means that C2 is equal to minus 2C3. Okay? C2 is equal to minus 2C3 from the second row. Because from the third row we cannot find anything. From the third row we cannot find anything. So since we have to use the second row. And from the first row, C1 plus 4 C2 plus 7 C3 equal to 0. So it means that now we can put the value of C2, which is equal to 4 into 2C3 plus 7C3 equal to 0. So C1 is equal to minus 8 C3 plus 7 C3 equal to 0. So C1 is equal to so I think here minus 8 C3 plus 7. So answer is C3, because minus C3 and plus C3, so we're remaining with minus C3. So minus C3 will go to the other side. So we got C1 is equal to C3 and C2 equal to minus C3. So if we are considering C3 any variable, let's say t, okay, then C1 will be equal to t, because we just put the value of C3, and C2 will equal to minus 2t. Okay, so it means that if you want to find the value of C1, C2, C3, you can find by writing t minus 2t and t, and answer is t should be outside, 1, minus 2 and 1. Okay, so we have find the value of C1, C2 and C3. Values are there. Now where is linear independence and dependence? We have found the values. So the way we solve the linear combination, the same manner we have solved this question, and we have found the value of C1, C2 and C3. Okay, so where is the idea of linear independence and dependence? So here is the idea of linear independence and dependence, that is the note. If C1 equal to C2 equal to C3 equal to 0, if all are 0, then whatever the vectors we have, we have y1, y2 and y3 are linearly independent. Linearly independent, otherwise dependent. So what is it? Dependent. That is the answer. Okay, so the system is linearly dependent, isn't it? You got the idea? The question is the same like the way we were solving the linear combination. Just to get your y, which is very very important, this part will always be 0. You will put always this part, this one, zeros if the question is relating with linearly independent or dependent. Okay, and the question will be solved the way we solved the linear combinations. Clear? So row 1 will remain the same, 0 plus 2 1 3 3 0 0 minus 1 minus 1 0 0 minus 3 plus 3 and 5
So we're writing it in the calculator.
5 0.
We're writing it in the calculator and we're resolving it.
Yeah.
Still typing.
So it's there now. So what I did, I multiply R1 with 2 and solve with R2, and 3 with R1 and solve with R4. That's what I did.
3 multiplied by minus 1, it's 1 left side.
3 multiply minus 3 multiply by minus 3, answer is plus 3 and 2 5. Okay, so now what I'm gonna do, minus 1 0 0 0 1 1 0 0 1 1 0 0 1 1 0. So what I did, I multiply R2 with 1 by 3, R3 with minus 1 and R4 with 1 by 5. Okay, done? R2 by 1 by 3, R3 by multiply by minus 1 and R4 multiply by 1 by 5 to get 0 1 1 0 0 1 1 0 0 1 1 0. So always remember one point. Okay, always remember in matrix manipulations or operations, when the multiple rows are equal, if they have become equal, so what is to be done? So by keeping any one of the row as a constant row and change all rows to the zeros, by keeping, you could see that this row, these 3 rows are similar. Okay, so what you will do, that you can do here, by keeping one of the row intact, the constant, and change rest of the alike rows, similar rows, to zeros. Okay, so what we're gonna do here, 1 minus 1 0 0 0 1 1 0, and rest we are converting to 0 0 0 0. Okay,
We
not
only
okay.
want the second one.
So if I'm writing by this way, R2 minus R3, R2 minus are 4. So then what would happen with this operation? Yeah. So minus 1 plus 1 answer is 0. Minus 1 plus 1 answer is 0. Minus 1 plus 1 answer is 0. So we just subtract rows with each other. Okay, we subtract row 2 with row 3 to get all zeros. We subtract row 2 with row 4 to get all zeros. And row 2 will remain the same because that one we are using to apply the operation. That is the leading element row. So that will remain the same. Okay, so this row has remain the same, the second one, and we are changing the third row and fourth row. So that's why when both of the rows are equal, so one will be eliminated. Eliminated means 0 zeros. So from here you can see that C2 plus C3 equal to 0. So C2 equal to minus C3. So it means that, and from this equation, C1 minus C2 equal to 0. So C1 C2. So it means that our system is linearly dependent, again because we have found the values of C. C is not equal to 0. C1, C2, they are not equal to 0. We have found something for C1, C2. So it means that the system is linearly dependent.
So what should it be for it to be independent?
All zeros. C1, C2, C3 will always 0 for linearly independent.
We find maybe C2 is equal to C3 or C1 is equal to C3 or whatever, and to be directly independent.
Yeah, independent.
Okay. And if we find maybe C1 is equal to maybe 1.
Yeah.
Dependent or independent?
For independent C1, C2, C3 all must be zeros. No any other option. Okay. If any of C is non-zero, it means the system is dependent. Okay, done? Okay, so we finish here, and next class will be very important, inshallah. More? This.
The first step, how did you put the first?
Matrix. Whatever the vector you have been given, write in columns. So this matrix 2 minus 1 0 3 will be written in one column.
No, I mean the leading element.
Leading element.
You change it to 1. How?
By switching the row 1, row 2. Row 1 with row 2.
I'm changing the sign.
Same multiply by I have written the operation as well.
Okay.
If you will get free, and if you watch the video or the lecture notes, you will see all the operation is there. Yeah.
You will just like this stuff.
Yeah. If you don't want to watch the video, still the one note is there already. Yeah, welcome. Both options.
What if I change the columns?
No.
No.
Oh, no.
Okay, what if I get one?
In matrix, when we apply the matrix operation, you have to choose one way, whether you want to apply the column operations or whether you want to apply the row operations. Once you choose you want to apply the column operation, so in between you cannot switch.
You can switch columns. You have to switch rows.
Yeah, you can switch. You have to decide first of all whether you want to apply row operation technique or column operation technique, because both can be applied. So once you decide that you wanted to apply the column operation technique, then you may not go for the row operation.
I did the column, I got C1 0 and the other values correct.
No.
So if one
and
value is
I
zero-
suggest you to apply always row operations.
And if one of the value is 0 and others are correct, still independent or dependent?
Dependent, because
One of it is
all values must be zeros. All. C1, C2, C3, all must be zeros to get system linearly independent. If any of the values, let's say you have 2 zeros and 1 non-zero, still dependent.
Still, about the exam.
Yeah.
When will it be? The Thursday?
Today I upload the result, inshallah.
No, because I didn't attend the exam.
You did not. So on
Yeah.
Thursday, let me figure it out
Can you
today.
make it on Sunday?
Because some students are they having the availability on Thursday. So let me see. I'll send you an email.
Okay.
So try to come to that time. If I mention any time in email, so whether it could be Thursday or any, I'll check